Good morning, everybody, and welcome to our webinar on flea beetles and seed treatments. My name is Karina Lepp, and I'm the Grower Engagement and Extension Manager with Manitoba Canola Growers. I'm so happy you can join us all this morning. Just wanted to start off with a couple of housekeeping items. The session is being recorded, and we will be sharing it out following the presentation. And we do plan to have a 15-minute question and answer at the end of the panel discussion. So please type your questions into the Q&A box. Also, following the presentation, a code for CCA credits will be displayed on the screen for you to scan. Now to introduce our panel speakers this morning, we are happy to have Justine Cornelson with us. Justine is the Agronomic and Regulatory Services Manager for Brett Young Seeds. She will be sharing with us why we are talking about flea beetles today and why they have been such an issue this past year. Up next will be Krista Anderson, Agronomic Solutions Manager of Seed Growth with Bayer Crop Science. Krista will be talking to us about seed treatments and how they work. Following Krista's presentation will be Dr. John Gavlosky, entomologist with Manitoba Agriculture. He will be sharing with us tips to improve foliar applications and some detriments to foliar insecticides. At this point, I would like to turn it over to Angela Brackenreed, agronomy specialist with the Canola Council of Canada, to kick us off.
Good morning, everyone. Thank you, Karina. Thank you, Manitoba Canola Growers, for giving me some time here this morning. I really appreciate it. As Karina said, my name is Angela Brackenreed. I am an agronomy specialist, and I also provide research support for the programs that the Canola Council administers. I'm only going to steal a few minutes here this morning to highlight some of the ongoing flea beetle research. I'll also be moderating the Q&A session that Karina mentioned at the end of the three presentations. So as she said, you can enter in your questions into the chat box. You can also use the hand raising function and ask them live at the end if you'd prefer. So the Canola Council administers research programs on behalf of the three provincial canola grower associations. So that of course includes Manitoba Canola Growers, as well as the entire canola industry. We have the annual Canola Agronomic Research Program, or as we often refer to it as CARP, as well as the federal government's Canola Agri-Science Research Cluster, which is a 5-year program. The growers also participate in funding through provincial calls and some projects individually. So to me, the real beauty of these programs is that the projects are selected and funded by growers on behalf of canola growers across the prairies and in Manitoba. So they're looking to fund projects that ultimately are going to improve yield and of course profitability and reduce overall production risk while also enhancing and improving our sustainability. The Canola Council annually sets research priorities through consultation with the canola industry, our growers, and expert steering groups. We have a really great resource in the Canola Research Hub, where you can find ongoing projects and reports from finalized projects. So some currently ongoing flea beetle research projects right now, we have 2 that are happening out of the University of Manitoba. So they're looking at things like the appropriateness of the current thresholds that we're using, thresholds for stem feeding, the impact of plant density, and of various landscape features around the field on flea beetle severity and feeding, and how things like interseeding can affect flea beetle feeding intensity. We also have a project based out of Alberta that's looking at predators for flea beetles. So they actually look inside the guts of predators that they collect out in the field to determine what they're eating. And this projects like this, and this could help us potentially support a biological control program. We also have a project that's looking at non-transgenic hairy canola. So hairy canola acts as a natural deterrent to flea beetle and other insect feeding. Current priorities include evaluating and identifying alternative management tactics and tools for canola pests, including flea beetles, modeling for dynamic insect pest thresholds. So we often aren't just dealing with one insect, we have many, and we also have beneficial insects that we need to consider. Reassessing pest control thresholds under modern canola densities. And lastly, technology and strategies to reduce off-target impacts of foliar insecticides and improve their efficacy. So thank you again to Manitoba canola growers. I really look forward to hearing these 3 great presentations today. I know from experience that there are a ton of questions about this particular topic, so I really encourage you to bring them forward at the end or enter them into the chat box. Enjoy.
Awesome. Good morning, everyone. Hopefully you can hear me. Let's see if Ange will nod. Yep, and see my screen. Perfect. So huge shout out to Manitoba canola growers for hosting this webinar, for inviting me. This was something that we were supposed to be doing at Ag Days. Unfortunately, that didn't happen, but we're still going forward through with this webinar just because it's such an important piece. And last year was a really struggling year as a whole, but never mind just managing flea beetles. So I guess my position on this panel is as an agronomist is to just kind of highlight what happened last year and really set the stage for our 2 experts to follow. So no, we don't want to go back to 2021, right? It was that drought year, lots of challenges, but we really have to understand the conditions that we were dealing with to really understand what happened with flea beetles. So when we think back to last year, we remember we had a really open spring. I think back, gosh, right around this time last year, there were growers in the field putting in cereal crops. It was really just quite amazing and very with an open spring, it was also very, very dry. So just got a precipitation map here. You can see the areas with the yellow and orange colors. They were around or under 50% of average precipitation. So we started off the growing season extremely dry, and some areas did eventually receive precipitation, but it ended up happening in kind of like flash flood type events. So yes, we got precipitation, but it happened all at once, and a lot of times this really ran off. So you can see some areas here where, western half of the province where I'm from, fairly dry or fairly good actually. We had some spring precipitation, but this come into later June. You can see areas in Manitoba within the Inner Lake region that really didn't get to see any sort of early spring precipitation. So that was the starting point. We were very, very dry. The next part, understand kind of what was going on and kind of building up to, why we had some flea beetles. We had a fairly cool May. Temperatures really fluctuated, right? We had some hot days, but we also hit some really cold days, and especially later on into May. So kind of past our typical, frost or late season frost window, where we got down to -10 in areas. And so this particular graph is just looking at the air temperature. You can see once again that Inner Lake region in Manitoba was really severely hit, where with temperatures up over that -10 range. So very, very cool. This was the last week of May, and this week really stood out to me because we went from freezing temperatures to heat wave within a week, actually within a couple of days. So this next graph just looks at the accumulated growing degree days. So you can see how hot the province was. That kind of, like I said, that first week in June, we had temperatures hitting almost +40. And, several nights prior to that, it froze. So not the greatest conditions for getting any plants up and out of the ground and established. Plants were extremely, extremely stressed out based on the conditions. So dry and variable temperatures. And I just want to move over to one more graph. So this is another really great resource from Manitoba Agriculture. I quite enjoy these maps because it kind of captures the month as a whole and what happened. So this is just a May extremes that are highlighted on this particular map. So we've got days where highest temperature. So the highest temperature was in Beausejour, 32.5 degrees, and that was the middle of May 17th. We've got areas where we had the greatest precipitation, being 80 mils. It goes into wind speed. So like I said, very extreme variable conditions that just really hindered any sort of good canola germination and growth. I'm not going to show the map for June, but we had, once again, these extreme temperatures. There was also a frost advisory later on, thinking to Saskatchewan, wide areas, Saskatchewan and Alberta had a really late season frost. It was, I think, the third week in June. So all of this stress just really built and I guess set the stage for flea beetles to do well. When we look at canola, there were so many different things that was happening, that was occurring to it. So we went from really cold temperatures and dry temperatures. With the dry conditions, a lot of canola producers were trying to chase that moisture. Usually it's that recommended 1/2 inch to 1 inch, but our topsoil was so dry. So if you were seeding it shallow and at that typical optimal range, it was sitting in dust. So there was no chance for it to germinate. So this was a kind of the balancing act. So we've had stuff that was way too deep seated, trying to find moisture, which this one or image shows. And then we had really shallow stuff. And some of the shallower stuff that popped up during that extreme heat was burnt right off at the soil surface. Something I've never seen before was this heat/wind burn. So just very, very severe symptoms. As the seed sat in the ground for so long, ran into seedling diseases. Acres were reseeded, and then to throw in one other factor, it was flea beetles, and that's obviously what we're going to focus on today. Is really understanding the situation that was and diving into our tools to better manage this. So with canola, right, small seeded crop, we know we've got to set it up for success, right? We need to do everything right for these plants to come up and out of the ground. And we know this starts right in the fall of the previous year with trash management. We know we can look at seeding dates and temperatures, right? We know what the conditions we need for this crop to do well. Last year, that wasn't the case. We were dealing with some of the most challenging conditions to get this crop established. And when we think to flea beetles, usually it's never just a flea beetle issue, it's a canola establishment issue. So usually there's something else paired with it. And last year we literally had everything else that could happen other than, I guess, probably excess moisture, maybe a few areas in the flash floods, but right, we had all of these other challenging environmental conditions that really favored flea beetles to do well and not the canola crop itself. So this is where a bunch of questions start coming up. When we talk on flea beetles, right, a typical presentation, we talk about thresholds, understanding our spray thresholds, when to put in an application. So we've got a good handle on this, and Canola Council's got a lot of great resources to help train the eye to assess different thresholds. I know John's going to talk about it a little further when we get into the foliar discussion. But that has been kind of the focus, and for today's webinar, we're going to dive in to the specifics of our products that we use to help manage against flea beetles. So we're going to kind of take a step back and really dive into understanding these products. So last year, on a challenging year, this is where questions come up, right? On a good year, when the crop comes up and out of the ground nicely, right, we can go through that really susceptible stage of flea beetles. There's no real questions or concerns about the products that we use. But last year, challenging year, questions start to come forward. So on our insecticide seed treatments, right, this is a proactive measure. All of our acres are treated. Questions like, how are the products taken into the plant? How long are they effective? What are the optimal conditions? options, differences between the products that are available. All of these things start to come forward when we have issues. And this is what Krista is going to really talk about and help us all better understand how these products do work. And then from there, John is going to discuss the foliar insecticide application, so the product options that are available, best environmental conditions to get the most success out of your application, time day, ideal plant staging, all of these different little components to make sure we are strategically using our foliar applications. So with that, I am going to just conclude with our insecticide seed treatment options, and Krista is going to take it on from here and dive into the specifics. We do have a few new options that have come available within the last few years. Last year, growers would have had a little bit of experience with Buteo Start, and a new one coming forward this year is Vocorus. So we've got some options. We've got a few different chemical groups out there, but Krista is going to, like I said, take it from here and dive into these specifics and how we can get these products in the ground and to do a really good job of controlling our flea beetles. So with that, I'm going to stop sharing, and I do have a poll question that will end up coming forward here, which there we go. Leanne's already on it. So in 2021, what was the single largest factor causing poor canola plant establishment on your farm? And we've got a bunch of different options here. It might not have been flea beetles. It might have been some of those environmental factors.
All right, I'll get you guys to let me know when I'm good to go.
Dry soils were the winner. Interesting. Okay, Krista, it's all yours.
All right. Okay, so thank you very much for the opportunity to speak to everyone today. I'm hoping that what you'll take away from my talk is just a better understanding of how the seed treatments work. I know from a decision perspective, there isn't a lot of options as growers that you have. You kind of get the package that you do, but hopefully when you come away from this, you'll understand why they behave the way they do, and when things work or don't work, you'll have a better understanding of why that is potentially, and just gives you a more solid understanding of what's going on and when you might have problems arise. So, all right. So I'm going to cover a couple of topics, a little bit about the modes of action, how these are active ingredients are uptaken and distributed in the plant, those factors that can affect efficacy. I do want to touch a little bit about resistance management and sustainability if we have time near the end. So first of all, there are two modes of action that we really have available to us as seed treatment insecticides for the flea beetles. The first group I'm going to talk about, first mode of action, is with the group 4 insecticides. That's our largest one. So these are the clothianidin and thiamethoxam, which have been on the market for 20 so years. Flupyridifuran, new kid on the block, just arrived last year, and then sulfoxaflor, which is in the Riscendo and the Fortenza Advanced. It's the advanced portion of the Fortenza Advanced. So they're different active ingredients. They have some different properties, which I'll talk about, but they do have some similarities. And the similarity is that they are all acting on the same receptor within the insects. So it's the nicotinic acetylcholine receptor, which is involved in synaptic transmission, which is basically neural transmission. So when there is a message that goes from the brain to the limbs, it goes through the neurons. It's a nerve impulse. And this is, so in your neurons, they aren't one solid, segment or strand that goes from the brain to the limb. They're little segments, and then there's little spaces in between these segments. And this receptor sits on the far side of the space between the neurons, and it acts kind of like a gate. So when a nerve impulse is going down from the brain, the receptor opens up a gate, lets the nerve impulse go through, and then it closes the gate. So what they get is these impulses, which is kind of like Morse code that sends a meaningful message down to the limb to tell it what to do. So what the group 4 insecticides do, they bind to that receptor and they open up that gate and they don't let it close. So instead of having this impulse, which is like Morse code messaging, meaningful, that goes down to the limbs, instead it's this constant stream and it is gibberish and it means nothing. And so the insect can't control its motors or its limbs and the movement. And so when that happens, it can be expressed in a couple of different ways. It could cause, hyperexcitation with, think of the jitterbug type of thing. It could cause the insect to become lethargic. It could cause paralysis. And eventually it leads to death. And that's an important thing to note. Death is not instantaneous when they consume these active ingredients. There is ingestion, and it takes a little bit for it to actually get into the system and then cause these bind to this receptor, and then for death to occur. There is a break between that ingestion and the death of the insect. Something else that's important to know from the neonics, or from the group 4, is that they're divided into subclasses. So class 4A is the neonicotinoids, and that's probably the one you've heard the most about. That is clothianidin and thiamethoxam. Those are the ones that have been around the longest. Sulfoxaflor and flupyridifurin are different subclasses within that group, different from the neonics and different from each other. So, and how are they different? Well, part of it has to do with the physical and structural chemistry of the active ingredients. The neonicotinoids within that class, all of those insecticides all have, greater than 50% similarity to each other. The butynoloids and sulfoxaflor, they have less than 50% similarity to the neonicotinoids, and they have less than 50% similarity to each other. And that's why they're into two different subclasses. And why is that important? And one of the reasons why that is important is because if you have resistance develop to one of these subclasses, let's say the neonicotinoids, then it does not automatically confer resistance to the other subclasses. So if an insect developed resistance to clothianidin and thiamethoxam, and generally when it does develop resistance, it is to the whole subclass. If they develop resistance to that subclass, it means that the other active ingredients within that group, the flupyridifurin and sulfoxaflor, would still be efficacious in managing that insect. And so that's why they are put into different subclasses, even though they are acting on the exact same receptor. So that's the first mode of action that we have available. The second one is with the group 28 insecticides. Those are commonly referred to as the diamides. We only have one active ingredient available to us for flea beetle management, and that's cyanotraniliprole. And that's what's found in both the Lumiderm and Fortenza. It acts on a very different receptor than the group 4s. It acts on the ryanodine receptor, which is involved in muscle control, but it's nothing to do with the messaging. What happens is, like the group 4s, it opens up a gate on this receptor, and it allows calcium ions to move from these little packages where they're contained within the cells, and does a mass dump of these cellular calcium ions into the muscles. Now, the calcium ions, when they're released like that, cause muscle contraction. And because it's a mass dump and it just continuously goes on and doesn't stop, those muscles can't relax. They become very rigid. The insect becomes paralytic, and eventually it dies. And so a slightly different way of achieving the same results as the group 4s, but also similar to the group 4s, there is that break between when the insect ingests and then when the insect dies. And we'll talk a little bit more about that now that I'm going to talk about the uptake and distribution in the plant. So something to note, regardless of the insecticide we're talking about, all of these are highly systemic. What that means is it gets is absorbed into the plant and then moves up through the plant tissues. There aren't a lot of insecticides that do this, that have this property. I'll talk more about that when we get to resistance management and sustainability, but you can be assured all of the active ingredients that we're talking about, they are all highly systemic. Now, when we apply the seed treatment to the seed, when it's in the bag, it is dormant. There is no activity going on between that seed and active ingredient. It's not being absorbed at that time. When you put that seed into the ground and it is exposed to moisture, and that water is start to be absorbed by that seed in the seed coat, there is a small amount of active ingredient that can move across the seed coat with that water at that time and be absorbed, but it's a very minimal amount. The vast majority of the active ingredients is actually absorbed through the roots. And what happens is you put the seed in the ground, there is some moisture, That moisture allows the active ingredients to release from the seed coat, and it forms a little bit of a halo around that seed and around the roots as they are developing and growing. And it is then absorbed and it's taken up through the water uptake system of the xylem, and it moves it up from the root system up into the foliar part of the plant and into all of the tissues. So uptake and distribution of the active ingredients can be influenced by soil moisture and water movement. And I think this is where a lot of questions come in and understanding what's going on, because this is one area where the active ingredients will behave differently. And I will be fully honest here, we don't understand how how these impact all of the active ingredients. I'm going to talk specifically about fluopyridifuran and clothianidin because I have data on those two active ingredients and what happens. We know that with fluopyridifuran, it is highly effective or efficient at getting into plant tissues under very dry conditions. And when we compare it to clothianidin, it is significantly more efficient at getting into the plant tissues under dry conditions. And by dry conditions, I'm thinking, 20, 30% moisture capacity. Under those conditions, you get significantly more fluopyridifuran than clothianidin. As that moisture level increases and the moisture capacity increases, the efficiency of the clothianidin to get into the plant tissues starts to improve, and they become equivalent at one point. And we theorize, I don't have all of the solid data, we have an ongoing study right now, that as that moisture content continues to rise, that clothianidin actually may be better at getting into the tissues, and that fluopyridifuran isn't. And now, why isn't fluopyridifuran as efficient at that point? We believe that when there's a high moisture level, is that it encourages the fluopyridifuran to move away, and that halo becomes too large and moves out of that root absorption system. And so why is this important to understand? It's because when you put your canola in the ground, if you have a dramatic rain event, let's say you get 1.5 inches in like an hour, within 24 hours after you seed, and there isn't a lot of moisture in the soil to begin with, and so it's moving through the soil quite quickly, it is more likely that it will move the fluopyridifuran or the buteo away from the seed than it will move the clothianidin or the prosper. And so that is one system where we do have some understanding. Can we apply that to the other active ingredients? We don't know the specifics of them. They could behave or show similar behaviors, but which AIs are doing those and exactly how, that I can't tell you right now, because I haven't actually looked at those ones. And I don't know if anyone has taken all of the active ingredients and actually looked at all of them individually. But I do know that one system, that is what's going on there. And I suspect it's why we've seen really good performance with the buteo under some very challenging spring conditions the last little while. One thing you do need to know is that any active ingredient that's taken up into the plant, it will be distributed among all of those tissues. It's not like anything gets left out. There will always be some active ingredient in all of those tissues. The concentration of the active ingredient in specific tissues may be a little bit different. So one thing, let's say the water intake, that water flow is consistent and the amount of active ingredient being brought up into that plant is consistent during, a bit of the growing process. What happens though is your cotyledons are very, very small. And so you have this active ingredient coming in and it goes into the cotyledons. And then you have the same volume of active ingredient coming up and it's going into your first and second true leaf. Well, there's a substantial difference between the surface area or the plant tissue of a cotyledon versus a true leaf. So the actual amount of active ingredient is consistently going, it's the same during that growing process, but because there's more tissue that it needs to cover, that concentration in some of the individual tissues will be lower in some of your later leaves and the true leaves than you see in the cotyledons. That doesn't mean there isn't sufficient active ingredient in there to be effective. It's just distributed a little bit differently. And as you can see in the photo, you can see there will be more concentrated around the leaf margins. So versus the middle. And what does this mean? It means in those areas where there's highly concentrated active ingredient, your flea beetle might only need to take one bite for that to be a full dose and effective and for it to stop feeding, versus let's say on you've got at your 4 true leaf stage, you can see in the photo, it's kind of blue instead of that hot red. If they take a bite in the middle of that leaf, they might need to take 2 or 3 bites to get that full dose and then die. But at the same time, those later leaves much larger surface area, they can tolerate more feeding than that little cotyledon can. And so you still get the efficacy, but the, how many bites need to be taken, that can change a little bit. So, but it is consistent. In order for these active ingredients to be effective, regardless of which AI it is, the flea beetles have to take a bite. And like I said, it's just how many bites they need to take may depend on where they took that initial bite. So some of the factors that affect efficacy, always at some point during the growing season, there will be someone who's like, my seed treatment didn't do what it was or what it was supposed to do. Why was that? So we've talked a little bit about the moisture conditions and water events, but there's some other things that also might be coming into play. So one of the questions that is floating around and people wonder is the resistance to that 4A class of chemistries, the clothianidin and the thiamethoxam. They've been on the market for 20 years. The insect population has been exposed to it year over year, and is that playing a role? And the answer is possibly, but we don't know for sure. And the reason why we don't know for sure is no one has actually been able or taken, no one has actually looked for the mutations in the flea beetles to see if they have that, that ability to overcome the insecticides. And that is something, there is a research group at the U of A, or being led out of the U of A, that is hopefully going to look at that and provide some answers in the near future. The work has just started, so it'll be a little while before we get those. But as I said, the answer is we don't know for sure, but anecdotally, we think there might be something there. Have the flea beetle population dynamics changed? Is it not just the chemistries, but have the flea beetles themselves and their behaviors changed? I mean, there is a lot of evidence that the striped flea beetles have moved in where the cruciferous used to rule, and that could be playing a role. Are the chemistries better managing one versus the other? And again, there's some anecdotal evidence, but no one's actually proven it really to a fine point. They also have different feeding behaviors. Is that playing a role? Also, there just seems to be more of them. Is it just sheer the fact that there are so many more flea beetles that they are overwhelming the chemistries? And if there was a lower population load, that they would still look as good as they did 20 years ago. And quite frankly, our environmental conditions have been very conducive to flea beetle survivability. And so they've been quite vigorous in reproduction and survival. Also, we've been feeding them more. Canola acreage 20 years ago was very different from the amount of canola acreage today. So did we contribute to creating this problem? Possibly. Resistance management. Standard base of resistance management is rotating classes of chemistry so you don't have resistance building up to one. From a seed treatment perspective, that isn't very pragmatic, especially when you look at the scale of canola and the logistics that are taken with having to get it treated, and the networks that would be involved to make that happen. And quite frankly, we just don't have very many options. Two chemistry classes is not a really good rotation strategy. Mixing different chemistries is an option. We've got a group 4 and group 28 insecticides. Mixing those, that's a good idea. There is a bit of a caveat though. Most of the diamide rates that we're applying on canola commercially are not the rates that are optimal for flea beetle management. And so from a resistance management strategy, that's a bit of a, that's not the best way to do things. Can we rely on mixing just the different subclasses? As I said before, if you get resistance to one, it doesn't mean there's resistance to all of them. Within that class, because this is used as a seed treatment and because flea beetles only have one generation a year, the chance of resistance developing to all subclasses is considered low, but it is not zero. And so that's something we need to keep in mind. From a sustainability perspective, how can we ensure that we can continue to manage flea beetles effectively with the seed treatments that we have? I mean, some people will ask, why not just find a new chemistry? It was 20 years for Bayer between when we released clothianidin and when we released flupyridipyrin. It is difficult to find active ingredients that are efficacious and have the systemic characteristics we need for an effective seed treatment. There are also increasing regulatory requirements that are making it more difficult to bring new chemistries to the market. As we better understand some of the risks that are involved to the environment and non-target organisms, there are more parameters that we need to meet and understand of those chemistries before we can put them through the registration process. That's not a bad thing. It's made us better. It is forcing us to provide better products. The caveat is, or the flip side is there are more studies that are involved. Those studies are much more complex than what they used to be. And there is a point where the cost and time required to meet those requirements, it may be counter by how much potential do we actually have to pay for all of that. And we're not at that point yet, but it is something that we keep an eye on. Also, our license to operate with our current insecticides options is not guaranteed. The neonicotinoids, they've passed multiple regulatory challenges, but they will continue to be targets, and they will continue to bear scrutiny from the public and also from the research community. And we fully anticipate that the other insecticides may eventually face those similar challenges. And so it's really important that we do the best that we can to manage the chemistries that we have right now, because we don't know when the next chemistry will come along. We also need to understand, because we have limited options, we have a risk with resistance potential developing. So we need to keep that into consideration when we're looking at what we're deploying into the market. And just constantly being aware that this is not a guarantee, and relying solely on seed treatments really isn't an option. Are there other things that we can be doing to help manage flea beetles and take some of the pressure off of an individual tool that we have in our toolbox? And that is, yeah, that's my part. So hopefully I didn't go too far over time, Angela.
Okay, so I'll jump into the next part of the presentation. I'm John Gavlosky, and I'm an entomologist with Manitoba Agriculture. And I'm going to tackle the topic of foliar insecticides for flea beetles in canola. And we had some trouble getting my my screen to show, so I'm going to say next whenever I want a new slide, and the wonderful people who are organizing, they'll be advancing for me. So we'll go to the next slide. So what we'll be discussing, I'm going to cover really 4 different things. I'm going to first of all look at what are the more susceptible stages to flea beetles. Then I'm going to have a look at thresholds and when is feeding too much. When do you need to start looking at a foliar spray? We'll look at what our foliar spray options are. And then we'll get into a little bit about how they work. Are they strictly by contact, or is ingestion an important component? Does temperature have an effect? Things that affect residual. So we'll be covering some of those topics. We'll go to the next slide. One of the things that I always try to stress to canola growers is that your biggest challenge really for controlling flea beetles or managing the damage is getting that plant to at least the 3 to 4 leaf stage in 3 to 4 weeks. And the reason that's important, that 3 to 4 weeks is important, we mentioned earlier that the clock starts ticking when you seed. The seed treatment being on the seed, it's not becoming active in any way. There's no biological activity when it's sitting in the bag. But once you seed, the clock is ticking. And if you get into a situation where germination is very slow and the plant is really struggling to advance through those very early seedling stages, that's when you are at risk. If you happen to be seeding into warm enough soil that you get quick germination, moist soil, and you get quick germination and quick early growth, there are years when you can get that canola to that 3 to 4 leaf stage within 3 to 4 weeks, and probably that seed treatment is going to be all you need. Now, most years aren't like that, unfortunately. We've had a few years in a row now where it was just not going to happen, getting the plant to that 3 to 4 leaf stage in 3 to 4 weeks. Anything that slows the emergence, whether it's dry soil, frost, or any of the other conditions that Justine did a really good job going over, that can impact this ability to get to that 3 to 4 leaf stage while the seed treatments are still working. So that is your big challenge. But again, some of the elements there are out of your control, which does help or does create the problem that we're dealing with. So we'll go to the next slide. So stages that are most susceptible to flea beetle feeding. The study that we usually refer to with this actually was done back in the 80s with some of the older varieties. And in that study, what they concluded was that yield was reduced most when plants were damaged during the seedling to second true leaf stage, but not reduced, at least not to the same level, when they were damaged during the third to fourth true leaf stage. I'm going to throw in a little maybe exclaimer here. This is generally true, but some of this does depend on the growing conditions. If you have decent growing conditions by the time you hit that 3 to 4 leaf stage, usually by then the plant can outgrow any additional flea beetle feeding. We have seen exceptions to this general rule or guideline. It's probably more of a guideline than anything else. We have seen exceptions, and last year was a year where we saw some of those exceptions. There were plants that were in that 3 to 4 leaf stage that just weren't growing quickly, and we still had some very high flea beetle pressures. And I do know of situations where fields in that 3 to 4 leaf stage were being sprayed for flea beetles, and rightly so. They were just being damaged way beyond what our nominal threshold is. And so the little exclaimer here is you can follow this as a general guideline. Once you hit that 3 to 4 leaf stage, you should be good to go, but still keep an eye on things. Don't stop scouting, especially if you know that there's environmental stresses that are holding the plants back. Do keep an eye on things. We'll go to the next slide. So the threshold that we've been using, and it was shown in one of the slides earlier by Justine, we use a threshold of 25% of the leaf surface area destroyed by flea beetles and flea beetles being present. That threshold, as Angela mentioned, is currently being reevaluated. It is somewhat of a nominal threshold. It's based on the best knowledge that we've got, but there are actually a few studies that are or have been and are trying to put more quantitative data to this threshold. It's been studied in Montana, in Sweden, and there's a big study going on right now across the Canadian prairies where we're trying to reevaluate this. So our current thinking, though, is that 25% is still the best guideline that we've got. But again, that could be updated depending on what this newer research shows. But regarding that threshold, there's a few other things that we need to keep in mind. So we'll go to the next slide. The study in Sweden, where they were looking at the threshold, they made the remarks in their conclusions that the economic thresholds preferably should also take into account the crop growth stage, crop growth rate, which I think is a very important one, and anticipated flea beetle activity. Now, crop growth stage, should the threshold be a little different at the 1 to 2 leaf stage than at the cotyledon stage? That's something that might be able to be teased out with the research. But I think the crop growth rate is a biggie. And we've seen this with other insects too, where if you do a study under good growing conditions, you will get one threshold. And if you redo that study under less ideal growing conditions, you get a very different threshold. And now, unfortunately, most economic threshold studies, they do the research and give you a number. And in most cases, a lot of cases, there isn't really a way to adjust it for growing conditions. There's a few exceptions to this. One that is sometimes used, a green clover worm in soybeans. There is a good growing conditions threshold and a separate threshold for less ideal growing conditions. That does require a lot of additional research to be done. You have to factor in things such as soil moisture, possibly heat stress, other things. It can be done, but it's something that at least the people doing some of this work have acknowledged that the, I guess, most accurate thresholds probably will depend on how well that plant is able to grow and compensate for flea beetle feeding. So we'll go to the next slide. This is our poll question. So just to get a handle on what the foliar applications were like last year, your options here for how many foliar applications did you apply? 0, 1, 2, or more than 2. Okay, so about 40% of people didn't have to do a foliar application. That's really encouraging, actually, because some surveys I know it wasn't that many. And a fair number did still have to do 2 foliar sprays, 17%, and 5% with more than 2. So foliar applications were done, as this shows, on about 60% of the canola acres last year. So that's quite interesting. So we'll move on to the next slide. And we're going to transition into looking at some of our foliar insecticides for flea beetles. So we do have a few different groups of foliar sprays that can be used on flea beetles. Probably the most commonly used ones belong to a group called the Pyrethroids. And this includes your products like your Decis, your Matador silencer, Upside Ship is another product, and Pounce Ambush, Permup, Ipco Synchro, that's permethrin. That group, the Pyrethroids, they all have a similar mode of action, and relatively they're fairly cheap products, and they tend to be the most widely used group. The other one that does get some use is 7XLR. It's a carbamate. It works by a whole different mode of action than the Pyrethroids do. Malathion is registered for flea beetles. I don't know that it's very widely used. And Volume Express may be used to some degree, probably not as much as for some of the Lepidoptera pests that it's registered for. With Volume Express, it's basically a combination of Matador and the active ingredient in Coragen. Now, Coragen is a great product on anything Lepidoptera, very good on grasshoppers. Beetles, it doesn't seem to have the same consistent activity on. And we see that even in potatoes with potato beetle and alfalfa with alfalfa weevil. Some of the beetles, it's suppression, but not to the same degree as it will control Lepidoptera, grasshoppers, some of the other pests. So now Coragen, if you've also got some cutworm concerns or other insects, maybe there's grasshopper nymphs coming out that you want to try to target as well, it will have that better residual for some of those insects. So there might be times and reasons where that's a very good choice. But as mentioned, the Pyrethroids are one of the groups that do tend to get a lot of use with the flea beetles and canola. So we'll go on to our next slide and look at how some of these products actually work. And I'm going to start with a study that looked at one of our pyrethroids, daltemethrine, and another product called Spinosa. Now, Spinosa is registered for flea beetles in cruciferous vegetables. It is not registered in canola. It's more of a hort product. But this particular study done in Saskatoon was looking at both of these products and the way they worked on flea beetles. So what they did was they sprayed flea beetles with these products. And for their other treatment, they sprayed seedlings. And they compared their level of control and the amount of damage to the plants. And what they found was that the topical spray, where they sprayed the flea beetles directly with daltemethrine or spinosad, resulted in lower mortality, so lower death and higher feed than when they exposed the flea beetles to treated canola cotyledons. So their conclusion here was that it's not, a lot of people have the misconception that you have to hit the bugs to kill them with the pyrethroids, and that's not necessarily true. There is residual action by the insecticide on the leaves, and in fact, if you only spray the beetles and only spray the leaves, you get better kill where they're feeding on the leaves versus with them just having been hit by the insecticide. So it is both contact and ingestion of the pyrethroids that is killing the flea beetles. So we'll go to the next slide. So with the ingestion, one of the questions that often comes up is, how many days should I be getting for prevention? It's a very complex answer to that. A lot depends on how long that residual hangs around, and that's going to be affected by things like temperature, photodegradation, volatilization of the product, and temperature is a biggie in that. If you spray at too high a temperature, you will get more volatilization and you will get weaker control, which will bring us to our next slide. Temperature and pyrethroids. So not only do you get more volatilization, but there's good research to show that once you start to get into the higher 20s, you just don't get as good control with some of the pyrethroids as you will at lower temperatures. So if you're using one of the products in that pyrethroid group, Desis, Matador, Ambush, something like that, ideally it's good if you can get those products on when it's not into at least the high 20s. Choose the lower temperatures if you can. So we'll go to the next slide. And the next slide is actually just a study that basically shows what I just told you. And this study was done with permethrin, which is your ambush, your pounce, your permup. They applied the product against flea beetles and a few other insects at some different temperatures. And bottom line, they got better control at the lower temperatures than they did once they got into the higher 20s and 30s. So we'll go to the next slide. Resistance in flea beetles. Krista mentioned this is being studied at the University of Alberta. There's a big study going on. If people are starting to see flea beetle feeding and thinking they might have some issues with resistance, please get in touch with me. We'll see if we can get a sample and get them sent in for that study. We don't have any data right now to conclude that we do have any resistance to foliar insecticides. But again, if you think you might be seeing that, let's see if we can get some of your flea beetles sent in for that study. So next slide. And I'm just going to conclude with a few comments on the challenges of applying basically all that I just said. First of all, assessing 25% defoliation is a subjective thing. It's something that you have to train your eye to be able to see and evaluate. There are a few good guides out there available. This one's pulled off of the Canola Council website, and sometimes having a good key with you is very helpful in determining percent defoliation. So we'll go to the next slide. So this particular cotyledon here, I'll get you to advance so people can see what this is. This is 10% defoliation. Generally, this is not going to be economical. Now, if you've got extremely dry conditions, even levels less than 25 could be economical, but generally a cotyledon like this with just a few pits is going to outgrow that damage. So go to the next slide. So the next slide is really beaten up, and you can see roughly half this tissue is damaged by flea beetles. So this is 50% defoliation, but in addition, you'll notice stem feeding. If the stem feeding gets serious enough, that whole cotyledon dies, and then it's essentially 100% for that cotyledon. There's a study going on right now at the University of Manitoba. They're trying to figure out what causes this stem feeding, or well, we know flea beetles cause, but what makes the flea beetles feed more on the stems is high wind conditions contributing factor, cooler temperatures. Are they spending more time on or in the soil feeding on stems? That's something that has to be teased out. Yeah. So we'll go to the next slide. And so this is my contact information. Again, if anyone needs to get in touch with me for flea beetle questions, or if you have flea beetles you want to contribute to our study, please contact me, and we'll see what we can do to get your questions answered or your flea beetles sent in. So I'll end with that, and we can hopefully move into questions.
Yeah, thanks so much, John, Kristen, and Justine. Those are three excellent presentations. We have lots of really great questions coming in the chat. We only have a few minutes to address them. So anything that we don't get to, we can be sure to follow up after. So the first question is for Krista. And sorry, yes, we have the CCA credits up here as well for those who are CCAs. So for Krista, how does systemic activity of current flea beetle insecticides, seed treatment insecticides, compare to a product like Lindane, which was used in the past?
From a systemicity perspective, they're probably quite similar. There's some it's a very narrow window of parameters that allow insecticides to be systemic, and it actually has a lot to do with how well they move across cell membranes. And there's some hydrophilic and hydrophobic components to it. And I'm not a chemist, so I can't tell you all those details. But if it's systemic, there's not a lot of difference in the systemicity. There might be some nuances, but the fact that it is systemic means that they've got some similar properties. Where they're probably seeing differences is the mode of action and how that behaves. And I will be honest, Lindane was taken out of the market about the time when I was just coming on with Bayer. So I don't have a lot of hands-on experience. And I don't know if John might actually have some input on that, just because I also work with fungicides, so my time is split, but John's devoted. So I don't know, John, if you want to add to that or not.
Yeah, Lindane, it was fairly quick acting. Residual time, it would have been very comparable to what the current seed treatments are. A little bit of repellency effect with the Lindane as well. It was a product they used to combine with other products such as Counter and Furidan granules, which are also off the market now. So in combination, you got that extended treatment against the flea beetles, much the same way we're now doing with our neonics combined with our diamides.
Okay, so another question that could probably be for all of you. First, for the first portion of it, in regards to stem feeding, sorry. The first portion of it, Krista, is there a concentration of active ingredient of the seed treatment insecticides in the stem?
Yes. So and remember that the insecticides actually have to go through the stem to get to the foliar parts. There will always be some level of insecticide present in any tissue that passes through. The flip side is that most of the stem is, the vascular system and water transport, so it's moving things through, and there isn't a lot of tissue around it for the insecticide to be deposited into, and it's being moved through. So the concentration that you see in the stems is probably less than what you're going to see in the cotyledons or in the leaf margins, but there is some insecticide there.
Okay. And for Justine or John, the impact of cold conditions or conditions generally on stem feeding activity.
Yeah, it's something that we see the beetles move down in. They're not super fans of cold weather or extreme heat, which we saw both last year. So you will see them move down into the canopy and start feeding on that stem more often.
Yeah, and just to add to that, now flea beetles, their metabolism slows. They feed less when it's cool. But if you get a situation where it's still warm enough that they are feeding, or they're down there because of extreme winds, that they don't like it too windy as well. And one of the speculations is that when it's very windy, they're spending more time in the cracks and hiding out and feeding on the stems. So that's one of the things they're trying to sort out with the study at the University of Manitoba. What are the main factors causing that stem feeding? Is it wind related, cool temperatures, combinations? What are the biggest factors? And if we know that, then it might at least help us determine when we're likely to see more of that.
Okay, so we are over time now. I'm gonna just wrap with two more questions and then I'll hand it back over to Manitoba canola growers. So there's a question on straight cutting and the impact of potentially having less volunteers. And it got me wondering about how or why the flea beetles end up where they do. So what is the impact of a volunteer population early on? Why do we see flea beetles so concentrated even in one area in a field and not at all in others, or in one field and not across the road?
I can handle that one if you want, Angela.
Sure,
There's
yeah,
been
go
a
ahead.
few studies that at least shed some light on what might be going on. Now, first of all, a couple of things. Flea beetles have a good sense of smell, and there is a chemical called isothiocyanate that plants release when they're damaged, such as by flea beetle feeding. Flea beetles are good at picking up on that. In high concentrations, this chemical smells like horseradish. But very low concentrations, you won't smell it, flea beetles can. They go to where it is. So once you get some flea beetles in an area feeding, it seems to attract others in. So things can be more concentrated. They move further and longer distances when it's warmer. Sometimes you get heavy edge effects. Other times they're right in the field. Sometimes there's a temperature factor that's causing that to happen. And as far as the volunteers go, whether they will actually do a lot of feeding on those volunteers or go somewhere else might depend on what else is in that field. We had a field last year up in the Northwest, very heavy volunteer canola population, but it was growing up into wheat that had already come up. And very heavy population of volunteers wasn't being touched. And there's no seed treatment on those volunteers. Right across the road was a canola field. It was being eaten. Well, they had to do foliar sprays on it. It was really being hammered, but right across the road, the volunteers weren't being touched. Flea beetles like those open canopies more than something that's growing into another crop or into a lot of stubble. And sometimes you'll see big differences in the populations just based on what is in adjacent fields.
Okay. Last question then for Krista, I guess. Buteo start. The attendee is wondering what the data shows as far as reducing the need for a foliar insecticide application.
Right. So we've only had 1 year on the market, and I will be honest, we hasn't been out long enough for us to actually make any conclusions or draw any conclusions. I can tell you though, when we were developing Buteo in our research plots, and keep in mind, when you do small plot research, you actually get more intense flea beetle feeding. We definitely saw, or we have theorized or assumed there will be a significant reduction in the need to spray. It won't eliminate it. Under really heavy pressures, there will still probably need to be some sort of overspray. We were hoping though that with the introduction that perhaps there wouldn't need to be as many, or it might be able to eliminate on folks who maybe only needed to do one spray, that perhaps they won't need to spray in the future. But quite frankly, we needed to be out in the market a little bit longer before we can build any data to truly understand that. But that was one of the things we were hoping for, that it would reduce the need to spray or even potentially to reseed.
Okay, thanks everyone, and thank you to the attendees for all their great questions. I had my own list of questions and I didn't get to any of them. So I really appreciate the engagement and all the questions. Thank you. Thanks everyone.
Well, thank you everybody for attending, and a special thank you to our presenters today. If there were any questions that were not answered, we'll go through them and email you directly some responses. So thanks again for joining, and I hope you have a great rest of the day.